After Hurricane Maria hit Puerto Rico, I helped a nonprofit distribute children's medicine to the islands. Much to my surprise, many of the resources that went to the island were entirely mismanaged, including this image where nearly a year later, over 20,000 water bottles were found completely unused due to the failure of organizers to allocate resources efficiently. After natural disasters, our systems fail us in our greatest times of need. After doing some research and informational interviews, we uncovered two key pain points in the disaster relief process. First, supply networks are generally not adequately managed or coordinated, so a lot of resources go entirely to waste. Next, we found that the lack of offline technology makes coordination very difficult. So, we developed aLocate. aLocate helps organizers allocate resources more efficiently by using offline compatible software and advanced data science analytics.
Our application is a responsive mobile web app that can work on just about any device, including computers, tablets, and even cell phones. The application is already pre-populated with the aid stations that are currently available. This allows workers to sync up before they go out into the field where they might have limited connectivity. Once an aid worker arrives at their location, they are able to add patients they treat at that location. As you can see, this aid station was just set up and doesn't have any recorded patients. Let's assess our first walk-in. After adding the patient, responders make a note of the status the patient is in and then add the supplies that patient is going to need for treatment. The aid worker then asks if the patient would like to share their health status and physical location with other relief workers and other victims. A relief worker can go back and edit any of this information at any other time to update the status. If the network goes down, the entire database is stored in PouchDB locally on the client device. It then syncs back up with the remote database once it regains connection to the internet.
Now we are going to demonstrate aLocate's backend component. aLocate synchronizes with IBM's Cloud and DB to provide powerful and insightful analytics about a disaster area using pixie dust. Our data is fed in from aid workers who use the front end that you saw previously. Here's an example where we plot the supplies of aid tents in Kathmandu after the Nepalese earthquake. Here you can see each point aggregates the total number of supplies found at each relief site. Furthermore, a data analyst can easily share his insights using IBM's Pixie Gateway. As additional specialists get involved with the effort, they can provide meaningful instructions to aid workers on how to properly allocate resources in an effective area. Finally, we're going to demonstrate a supply chain optimization algorithm that uses reinforcement learning. We use a Markov decision process to map out the optimal outcome space of a supply allocation scheme when we sample demand modeled by Poisson random variables. Here we can see a grid that shows the best way to move resources between two locations given pre-specified estimates of demand. Thanks for listening. We're looking forward to bringing aLocate to affected communities around the globe.